Hello students, welcome back to another exciting session on calculus. Let me begin with a thought. Imagine you're preparing for your exam and you see the same type of integral appearing again and again. Would you really want to rederive it every time? Of course not. That's where standard integrals come to the rescue. These are like ready-made tools, short, powerful formulas that save you from long calculations. And once you recognize the pattern, you can directly apply the formula in seconds. Let's now explore some of the most important standard integrals. Our first standard result deals with the difference of squares. The formula is integral of dx over x squared minus a squared equals 1 divided by 2a log modulus of x minus a divided by x plus a plus c. Let me say it clearly. Dx over bracket x squared minus a squared bracket equals 1 over to a log modulus of x minus a upon x plus a plus constant c. This result is obtained using partial fraction decomposition. And don't forget, the modulus sign ensures the formula works for both positive and negative values of x. Now let's flip the denominator and see what happens. The formula is integral of dx over a squared minus x squared equals 1 divided by 2a log modulus of a plus x divided by a minus x plus c. In words, dx over bracket a squared minus x squared bracket equals 1 by 2 a log modulus a plus x upon a minus x plus constant c. It looks very similar to the first formula, but notice the reversal. The denominator has a squared minus x squared instead of x squared minus a squared. That's why the terms inside the logarithm are also reversed. A very common exam trick is to confuse these two. Here comes another very popular standard integral. The formula is integral of dx over x squared plus a squared equals 1 divided by a tan inverse of x upon a plus c. Clearly spoken, dx over bracket x squared plus a squared bracket equals 1 over a tan inverse of x by a plus constant c. This formula is usually derived by substituting x equals a tan theta. The beauty of this formula is that it has no restrictions on x because x squared plus a squared is always positive. You'll find this integral everywhere from physics to probability. Now let's take 1 with the square root in the denominator. The formula is integral of dx over square root of x squared minus a squared equals log modulus of x plus square root of x squared minus a squared plus c. Clearly, dx over root of bracket x squared minus a squared bracket equals log modulus of x plus root of x squared minus a squared plus constant c. This result comes from substitution x equals a sec theta. But remember the domain, this formula only works when the absolute value of x is greater than a, otherwise the square root is not real. Alright math explorers, now we are going to double check one of the coolest ideas in calculus, the antiderivative. So, here's the claim, the integral of cos x dx is sin x plus c. Now, how do we know this isn't just mathematical gossip? Let's test it. Step 1. Assume f k smiley is equal to sin x plus c. Easy enough, right? Step 2. Differentiate it. Take the derivative. What do we get? Boom. Cos x. And guess what? That's exactly the function we started with. Moral of the story, integration and differentiation are like best friends checking each other's homework. If you integrate cos x and then differentiate the result, you land right back where you started. Oh, and about that plus c, constant terms are like invisible ninjas. They're always there, but they never affect the derivative. So, verification complete, the antiderivative is officially confirmed. High five, calculus. Now you may wonder, why are these formulas so important? In physics, they appear in problems involving electric potentials, oscillations, and wave motion. In probability, they form the basis of the Gaussian curve and normal distribution. In economics, they appear in growth and cost functions. So, by learning these 4 standard integrals, you are preparing yourself not only for exams but also for real-world applications. Let's recap the 4 standard integrals we studied today. Number 1, dx over x squared minus a squared equals 1 by 2 a log modulus of x minus a upon x plus a plus c. Number 2, dx over a squared minus x squared equals 1 by 2 a log modulus of a plus x upon a minus x plus c. Number 3, dx over x squared plus a squared equals 1 over a tan inverse of x upon a plus c. Number 4, dx over root of x squared minus a squared equals log modulus of x plus root of x squared minus a squared plus c. These formulas are your integration shortcuts. They save you time, prevent silly mistakes, and are guaranteed to appear in your exams, and that's the foundation of standard integrals. In the next video, we will explore how to apply these formulas in solving more complex problems step by step. See you there.